So I'm starting this afternoon talking about benchmarking. And well, for a consortium like OW2, benchmarking a software forge, or what we call nowadays application lifecycle management platform, is, I think, of interest. Especially because the Orange Forge is based on Tuleap software, and OW2 today is now experimenting this software. This work has been carried out with two co-workers here, Christian and Romuald. Okay, so this is basically an experience of practically using CLIF to benchmark a software forge. So what is Orange Forge? Orange Forge is the software forge for the Orange Labs, which means R&D, but not only R&D at Orange. It's also open to the Orange Group and also to external partners, and it's a worldwide platform. We have more than 1,000 users, different users connected daily, more than 16,000 registered users, and more than 5,000 projects, active projects, very important. And the Orange Forge trackers are also widely used for a number of support teams. So, for example, if a project requires a number of virtual machines to build its platform, is using the tracker to put a ticket and to ask for resources. And of course, the support of the Forge itself is based on the Forge trackers. Okay, as any Forge, it integrates a great variety of services: CVS, SVN, Git, wikis, trackers, documentation and package management, download management, a number of agility tools, mailing lists, continuous integration, and so on. It's a Forge. And well, this year we had, at the middle of this year, we had to move to a completely new infrastructure with new servers, new filers, new network, and also we did an upgrade of the Tuleap software and of the Linux operating system. So, of course, the critical questions were, will this new platform stand the incoming traffic? And what will be the quality of experience? So the necessity was, of course, to do some benchmarking. So the idea of benchmarking is that you have an arbitrary system under test made of a number of servers or whatever, and you are going to use some load injectors, which are just machines on the network that generate some traffic according to a given scenario using some specific protocols. Well, these load injectors are going to generate requests and submit these requests to the system under test, and they are going to measure a performance metric like response time or throughput, things like this. When you define a benchmark, you specify the system under test and its interface. You define the incoming traffic, which will be a mix of some typical kinds of requests on the system interface. And of course, you also specify a metric of interest, because the goal of benchmark is to compare the performance of different alternatives. So each time you change something, you will get this metric as a result, and you will be able to compare. To do this, we use the CLIF because, well, Orange is leading, has created this project more than 12 years ago in Object Web and then now OW2. And we are still leading this project. The peculiarities of CLIF, these are the reason why we created this project, because there are some others comparable, but not with these features. The first thing is that it's generic and extensible. So we can use it for a variety of IP-based protocols, voice over IP, database, mobile networks, arbitrary protocols. It's flexible. It's provided through a number of environments, like Eclipse-based environment, pure Java software. You have also several command line tools based on Ant, on shell scripts, or on Maven, and there is also a plugin for Jenkins to drive and to generate test reports. We say that it's advanced, CLIF is advanced because we can manage millions of virtual users. The question is just to know if these virtual users use a lot of resources or not, of course. But there are no real limit. For example, we use it for the set-top boxes and all the domestic gateways, the live box. When we want to emulate the traffic of these devices, well, we have hundreds of thousands or millions of such devices, but they do little traffic each. But we have no trouble to emulate this kind of benchmark. CLIF has been used up to more than 1,000 load injectors in parallel. And well, there are a number of miscellaneous facilities that you don't necessarily find in other projects. And now we consider it as mature, because we had a lot of feedback internally and externally, thanks to CLIF being in open source. And we have also this plugin for Jenkins, which can be viewed first as a web interface to CLIF, and also it can be used, of course, to do some performance testing and continuous integration. And what is very convenient in our use case here is that we will be able very easily to run tests, because it's just a web console, a web interface, and also because it generates automatically the performance reports for each test, and also you have the performance trends, from one test to another. So here is a schema of the OrangeForge platform. When we started this benchmarking campaign, we had 3 platforms. The current production, the quality assurance platform, which is just for tests, and also we have the new production, the future production, which is the one that is currently running today. And on the same network, we have the 3 load injection machines. Okay, and we have also, which is used for the benchmarking campaign, and we have also another load injector which will generate a thin load injection, and which is not directly on the production network. Here it is in the Orange Labs production network. Okay, so when we started to think about benchmarking OrangeForge, of course we thought about the best practices, but then we were confronted to reality. The best practices in benchmarking is that first you have to write realistic scenarios. And for example, you can start from the logs of the platform, of the service, to get the right request and to define the scenario. But the reality is that there is a mix of a lot of different protocols. Most of them are based on HTTP. So all the logs mixes all these HTTP requests. The logs are too low level. So it's very complex, and the usage also is very variable. It depends on the hour in the day in the week, or during the weekend, during the holidays or not holidays, and so on. So it's really, really hard to figure out what is the the average traffic, and what are the real protocols that are used, the tools. Okay, so the other, very hard point here about defining the scenarios. The other point in best practice is that you will run the benchmark on both the new platform and the exact copy of the production platform, but without the production traffic. Okay, so there should be no users, and you generate the same traffic on both. But the problem here is that our quality assurance platform is not equal to the production platform. It has less resources, it's less powerful, so we cannot do that. We cannot generate the same traffic on this platform because it won't be relevant. Okay, so second problem, we don't have a quality, an ISO production platform. And then the third point in best practices is that you change only one element at a time, and then you can really compare the influence of this parameter, of this element. And this really helps troubleshooting and knowing what to do to increase performance. But well, here it's bad luck, but we have all new hardware, all new software, another operating system, new filer, and so on. So there are a lot of changes at the time, and so, well, we cannot do the best practice. So we had to adopt a pragmatic approach. First, we choose a number of services, and we define user scenarios related to these services. So we defined an SVN checkout and commit scenario, a Git push and fetch scenario, a scenario also who is browsing the web portal, and then which is using some agility tools, and also having a look at the SVN tree, the Git tree, some trackers, some forums, and so on. Fortunately, the APIs between the previous version of Tuleap and current version did not change. So we can really define the same scenario and run on the old version, on the old production, and on the new version. Well, secondly, well, we have, of course, to create data sets, which means we have to provision a number of projects, of users, of repositories, and database contents so that we can run the test. So we started from existing projects. The thing here is also that there is a lot of variability from one project to another. Some will have a lot of data, probably with a very small number of big files, very big files, and sometimes it's the contrary. So here again, it's very hard to figure out what is the representative data set. So, well, we try to do a number of things and different scenarios with big repositories, small repositories, and so on. And third, for each service, we run the test and we compare the performance of current production with the performance of the new platform. But of course, well, the old platform is submitted to the real user traffic, while the new platform, well, is either empty, there is no traffic, or we have to generate ourselves some background traffic using these scenarios. And finally, I think what we took as a reference to see that, to check if our workload is comparable to the real workload is the network throughput. It was the easiest way. Well, what was interesting in using CLIF for this benchmark? Well, first, we used the provided HTTP injector for all web-based tools, but I would say that almost all benchmarking tools have an HTTP generator, traffic generator. But what is really valuable with CLIF is that we could develop our own SVN injector and Git injector plugins, to generate traffic for SVN and Git. We use the CLIF console itself because it's based on Eclipse. So you have already, when you install the main CLIF console, which is the main CLIF GUI, you have finally you have a Java development environment. And what we did is that we took some existing Java clients, Java stacks for SVN and Git, and we just wrapped them into a CLIF injector. Okay, so what was really interesting with this SVN and Git injector is that we don't have to provide a data set in this case, because when we do some commit, we generate files and file contents on the fly in a random manner. So we don't have to have a pre-existing repository. And in the other way, when we do some checkout or some fetch, actually we just discard the data. So the load injector is not overloaded with that. That's really an advantage. Okay, what we did also is that we used the CLIF probes, which are provided with CLIF. So on the server side, we could check the usage of CPU, of memory, and so on, also of the network bandwidth. This was very important. We did the same at the load injection side, because we wanted to check that the load injectors were not themselves saturating. You have to check that the load injector is very healthy. Otherwise, the scenario won't be the one you have defined, and the measures will be biased. Okay, and so what was interesting also is that with CLIF you separate there is a concept of test plan and there is the concept of scenario. And within a test plan, you can mix a number of scenarios and deploy them of one injector or another. So it was very convenient to be able to reuse scenarios in a number of ways without having to merge them. And also it's very easy to take a scenario to change the number of virtual users depending on the workload you want to generate. Okay, so now let's go to the benchmarking campaign itself. So the first step was to get a reference benchmark starting from a current production platform. So the Orange Forge users are there. They generate naturally some requests and background workload on the production platform. And then we did some, we run our scenarios, but with a unit traffic, which means with just a single virtual user. And so this way, on one service at a time. So we can have reference performance in terms of response time, mainly, for the production platform with the real traffic. Then the step 2 is that we are going to compare this reference performance with the new production platform, but with just the unit traffic on the new production platform, which means there is no other background workload. And of course, what we expect is that we must have that the new production platform must be always faster. And finally, it was not the case. So we had to work, and we found a lot of defects in the setup. And so this step was really important. We had to fix a number of things. The third step is that we compared the new production, the performance of the new production, but this time with heavy traffic. So this time we took our scenarios, but we deployed them on 3 load injectors, and we increased the number of virtual users. So we had 3 load injectors, a mix of all services, web, SVN, Git, and so on. With multiple sessions, we had 100 active virtual users simultaneously. And we checked that the network bandwidth was close to that of the real traffic, which means it was about 200 or 300 megabit per second. And then we compared once again with the reference performance. And here again, we found a number of problems that we could fix. And, well, of course, the idea is that the new production platform should be globally faster. Here is an example of what we got, the results we got. This is the Jenkins+CLIF web application with the CLIF plugin. And automatically, the test reports are generated at the end of a test. And here what we see is the trend, the CLIF performance trend. So that means that we have 8 here, for example, we have 8 test runs. And we can compare the average response time in blue, the boxes in blue. In red, it's the maximum response time. In the point in deep blue, with just the line, is the minimum response time. And you have the plus or minus the standard deviation, which is the mustache around the average. So we could easily see here, when we change a parameter, either if the performance was better or worse. We see, for example, that the 2 last are really better than the previous ones because we changed something really important. So for each kind of request in our scenarios, here you have the login, you have the view of the agile dashboard. Well, I cut the remaining, but for each kind of request, you see the response time and the evolution of this response time when you change a parameter. Okay, in step 4, then we tuned the new production platform. So here we say, okay, performance is fair compared to the old production platform, but probably we can do better because we have a new hardware which is more powerful, we have more resources. Okay, so we still run our heavy traffic scenario with 100 virtual users on all services. But now we put some probes and we can see if the CPU is okay or not, if the memory is full or not, and so on. And we compare, of course, we tried to change the resources, added CPU or change the RAM configuration to see if we can increase performance. Okay, so so during step 2 and 4 and 3, as I said, we found a number of problems. The main problem is that the PHP cache was not working because it was a very stupid problem about a package which was renamed in Debian. I think it was in Debian. A new version with another name, and so the PHP cache was not working. And we found this. Oh, Red Hat. Sorry. And finally, we found that thanks to the Tuleap's embedded administration tools, we found that if this cache was empty and was not working, so we could fix it. Well, most of the problems were really related to caches, and we saw that because the first test run was very bad in performance, and if we do another test, it was much better. So it shows that at the first run, the caches were not working, and then it was working. We had also some problems with the load injection itself, and this is very a classical point here. You really have to check that your load injection system is performing all right. And the problem here is that the network infrastructure at a certain point was on a switch, just fast Ethernet switch with 100 megabits per second. And we saw that we go far beyond this limit. And so our traffic was limited to 100 megabits per second. And first of all, you don't know if it's a problem with your system under test. You say, oh, it's saturating, or what's happening? No, you have first to think about a problem in your load injection system. And so we could fix it. We changed the network equipment, of course, to go to 200 or 300 megabits per second. So we found a number of things about the version of the Linux kernels using NFS over local disk. Also moving the temporary directory to memory was also an interesting thing. Well, all these are a lot of details, but you can have a gain of 10% or 20% or more with such details, with each of these details. And step 4, which was the tuning of the platform with the probes, was very, very interesting because we saw that the memory, the RAM, was oversized. We did not need so much RAM. So this is the reason why we took part of this RAM and we put it we affected it to the temporary directory. And also we found that the CPU was really, really overloaded. And so we increased the CPU. These are the average performance gain, speed up, we got with step 4. So we, by tuning and just by adding a number of processors and by moving the temporary directories to RAM. It's an average of 30% speed up. Here you have, it's for each kind of request. So you have the SVN commit, the agile backlog, agile card wall, and so on. Okay, finally, step 5 is that now we have defined all these scenarios to see the response time. We can use it to monitor the quality of experience of the forge. So this is a reason why we have this load injector, which is outside the infrastructure, which is on the same network as we used every day when we connect to Orange Forge. And so we can monitor the response time and the quality of experience. And we can, we use here the periodic test run, which is enabled by Jenkins. You see that we have these trends of performance, and we can set some notifications to the platform administrators when something is going wrong or too slow. Okay, so now it's time for conclusion. So first of all, we were confronted to the deep complexity of benchmarking. It's true that I'm leading the CLIF project for more than 10 years, but I'm more a Java developer than a benchmarker. And, so I discovered or rediscovered a number of things. So the key thing is to identify and to be able to define realistic scenarios and data sets, and this is very complex. I've been reported that in many benchmarking campaigns, it's the more costly step is defining scenarios. So we had to simplify, we have to cope with it and to be pragmatic. We didn't have also a lot of resources and a lot of time. We had to go quick. So beware, very important, beware of the defaults at the load injection side before saying that your system under test is not performing okay. Check first your load injection system and use complementary monitoring tools to troubleshoot when you see that performance are not all right. It may be a network issue or something else. Not necessarily your system under test. And when it's your system under test also, by using monitoring tools, you're going to identify what are the resources that are short. We experienced the high efficiency of CLIF and Jenkins. We did really a lot of test runs, changing one parameter and running a new test and getting automatically the new performance report. So most of the time here, we did very short, few minutes, short tests, just a few minutes, so we could have a very quick feedback and say, okay, this change was good or it was not good. Of course, it was a very easy with CLIF to mix all these different protocols. It's very easy with CLIF to do that. And to reuse scenarios in different test plans with different objectives. Okay. And then it was definitely a good idea to benchmark. We have no doubt today that without this benchmarking campaign and the tuning we made, the service would have crashed. It's clear. So we avoided big troubles. And now, well, we can benefit from the work we did here with the scenarios to monitor the quality of experience. Okay, thank you.